Hi dear students, today we have come with a new video of class 10. In the previous part we have discussed about the calorimetry part 2, that is change in state and latent heat. Here today we will discuss some numerical from your exercise, that is concise physics. Okay, so it is not possible to do all the numericals here, so I will just choose 5 or 6 important numericals here which several times come in exam. So that numericals I will do. Okay, see what process I have followed and what thing I have told. Okay, and then I think it is very much easier for you to do that type of numericals. Okay, so I'm having your book. So we will do the numericals of exercise 11b. So I have to mention here, this is a numerical of exercise 11b. Okay, so we have to start from an easy numerical, that is numerical number 3. So maybe what numerical is there given, it is not same with your book, but I am reading that numerical, so just find it in which number it is given. So question number 3, it is given a molten metal of mass 150 gram is kept at its melting point, that is 800 degree centigrade. Molten metal means the metal is already melted. Okay, so what is the mass? So what thing is given, we have to write first. M equals to 150 gram. Okay, melting point means the temperature it is given. So temperature it is 800 degree centigrade. What thing is told? It is told when it is allowed to freeze at the same temperature, it gives out 75,000 joule of heat energy. So when the metal is already melted at this temperature, when it is allowed to freeze, how much heat it just gives out? The heat is equals to 75,000 joule. Here you have to understand, at same temperature. So at same temperature, whenever you have to liberate it or when you have to absorb some heat energy, so that heat is nothing but the latent heat. So it is the latent heat, total latent heat, which is exerted by the molten metal. Okay, now to come the first question, what is the specific latent heat of metal? Question number 1, we all know that latent heat Q equals to M into L. Okay, latent heat Q equals to mass into specific latent heat, where L equals to, we all know, specific latent heat. Okay, so this L you have to find out. So L equals to Q by M. So put the values here. Q equals to 75,000 by 150. Okay, so 0 0 15 5s are 20. So it is 500 joule per gram. Why? Because the mass is given in gram. I have already told that maybe that is not a unit system, not a unit of any unit system, but that unit we can able to use. Okay, so if you see the answer of your book also, it is given 500 joule gram inverse, that is joule per gram. Okay, coming to question number 2. What is the question? It is told if the specific heat capacity of the metal is 200 joule kg inverse Kelvin inverse. So specific heat capacity means, we all know, we have done in the previous part, that specific heat capacity, that is denoted by C, small c. We have learned it mc del T. So C equals to 200, how much? Joule kg inverse Kelvin inverse. Joule kg inverse Kelvin inverse. So that is its specific heat. What it is told, how much additional heat energy you will the metal give out in cooling to minus 50 degree centigrade. So here the temperature you have to take into minus 15 degrees centigrade. So we can say that should be the final temperature. So final temperature TF is equals to how much? Minus 50 degree centigrade. So what about initial temperature? Initial temperature we have already mentioned that initial temperature is 800 degree centigrade. So it is Ti, we have taken 800 degree centigrade. Okay, so what we have to find out the total heat energy. So we know that heat given out or heat liberated is equals to H, that can be denoted as MC del T. So del T is what? Temperature difference. What is the value of M here? 150. What is the value of C? 200 joule per kg. Now here there is a problem. Here it is mass is given in 150 gram and here it is given in 200 joule per kg. So here we have to convert it joule per gram. Okay, so 200 by 1000 joule gram inverse. Kelvin inverse is given. So we know Kelvin inverse and degree centigrade inverse, that is basically used to show the difference of temperature, and that is same. Okay, we have done earlier. So it is degree centigrade inverse. We can write it. Okay, so it is 0.2 joule gram inverse degree centigrade inverse. If you keep it Kelvin inverse also, there is not a problem. So it is 0.2 because here it is kg and here it is gram. That's why the conversion is done. If you want to convert this gram to kg, here you can do it. There is not a problem. If you want to convert gram to kg, that can be done, or here you have to convert it, okay, into del T, that is temperature difference. So what is the temperature difference here? 800 minus of minus 50. So it is clearly 850. So it is 150 into 0.2. So we can write it is 30 into 800 minus of minus 50. So it is 850 multiplied 3 5s are 15. Okay, 1 3 8s are 24. 1 25. 2 zeros are there. So this much amount of joule. Okay, so this much amount of joule heat energy you have to liberate it to take that metal into minus 50 degree centigrade. Okay, I think it is bit clear for you. Now we'll go for the next numerical. Okay, so for next part we will choose the numerical number 6. It's very interesting numerical. Okay, so we'll go for numerical number 6. So better I'm choosing that type of numerical which seems to be little bit of difficult. Question number 6, I'm telling you one thing, this numerical, out of the total numerical here given 12, 6 is a typical numerical, and that numerical comes in exam several times. Okay, it's a typical numerical. See it and try to understand what process I have followed here. Okay, so question number 6, what it is told? It is told find the result of mixing 10 gram of ice. So what thing is given here? So whenever we have to start reading the numerical, before read the whole numerical, we have to start the write the information. So mass of ice, Mi, we have to denote it, and what should be its value? That is 10 gram. At temperature minus 10 degrees centigrade. So temperature of ice, how much? That is Ti minus 10 degrees centigrade. Okay. It is mixed with 10 gram of water. So here we have to write, we can write here mass of water, that is also given, that is 10 gram, and temperature of water is also given here. How much? You see, temperature of water, that is also TW, that is 10 degrees centigrade. These are mixed. So it is very much clear that ice, what it will do? It will just taking heat energy from the water. Okay, it will absorb heat energy, and what will do this one? It will reduce heat energy. Okay, so this is the hot body, we can mention here, it is the hot body, and here we can mention this is the cold body. Okay, now what it has told? Specific heat capacity of ice. Specific heat capacity of ice, that can be denoted as Ci. What is the value? The value is 2.1 joule gram inverse Kelvin inverse. And what is the specific heat capacity? You all know that specific heat capacity of water, that is denoted as Cw. Okay, not as classwork. That is specific heat capacity of water, that is 4.2 joule gram inverse Kelvin inverse. One extra thing is given here, that is specific latent heat. Specific latent heat of ice, that is 336 joule per gram. Many more thing is given. Okay, so it is asked that what should be the result. Now in the question there is a confusion. What means the result? What is result? The result is, if you mix it together, then simple thing that water will lose heat energy and ice, they will start increase their temperature, they will gain heat energy. So when ice just gain their temperature from minus 10 degrees centigrade, it will increase up to how much? Up to the ultimate value, that is 0 degrees centigrade. And when this much water we have given, that will also taking heat energy, losing heat energy, so its temperature will decrease up to how much? Now that is the final temperature, 0 degrees centigrade. So here this thing you have to understand, you have to mention that here final temperature should be 0 degrees centigrade, because ice, it will reach up to 0 degrees centigrade by increasing its temperature, and water, it will decrease its temperature and it will go up to 0 degrees centigrade. Now the question has come, that is the state change. That is the result, that it is not like that the water will convert it into ice, because if it reach 0 degrees centigrade, then it is difficult. So to convert it, you have to liberate heat energy. Where you have to liberate? Here, ice, it can able to melt. Melt means it can able to change the state. That things can be done by ice. It is possible, but water is converted into ice. This thing is not possible. Okay, so here we have to assume, let m gram of ice will convert into water of 0 degrees centigrade. See, there is a big story. Okay, m gram of ice will convert into water, and rest of the ice that will be at 0 degree centigrade. Only m gram will change its state. If you see the answer, you'll understand here the result. We want to know that how much of ice will convert into water out of 10 gram. Okay. Now we have to come to the principle of calorimetry. So before that, we have to find out heat absorbed by ice. So heat absorbed by ice, whenever we have to tell it. So here we have to see two phases. What? Now one, minus 10 degree centigrade to ice to 0 degree centigrade of ice. That is a phase. Okay. And then 0 degree centigrade of ice to 0 degree centigrade of water. But here also one thing you have to mention, this thing, it is done by whole ice, but this is done by m gram of ice. Now you can ask, sir, why it is not whole ice? It is not possible to convert whole ice into water because whole temperature is coming to 0 degree centigrade. And if it is whole also, assume if the m means the whole ice, that also we can able to calculate by the process. What should be the value of m? That we'll see what it will come. Let's see. So these two phases are there. So minus 10 degree centigrade to 0 degree centigrade. Here we have to mention mass of ice mi Ci into del T plus. Okay, so that is the heat absorbed by ice, that is Q1, plus m gram of ice which is converted into water. So m into L. Why? Because you know that is to convert at same temperature from one state to another state, you have to absorb the latent heat. So here m into L is the latent heat. We have done it in the previous numerical also. Now put the value. Mi, what is the value? 10 gram into value of Ci 2.1, and then temperature difference, where it goes minus 10 degree to 0, so we can write it 0 minus of minus 10. Okay, now write 10 into 2.1, I'm sorry, next part is it should be added, that is plus m, the value of m we don't know, into value of L, that is 336. See it, whether you are able to understand or not. I think it is clear. We are finding how much heat is absorbed by ice, and here in this sort of numerical, as we are assuming some state has been changed, so that's why we have added this energy, that is a form of latent heat. Okay, try to understand, I think you will get it. Okay, so write the value here. 10 into 2.1, it is 21, and here also it is coming 10, so it is 210 plus m into 336. So this much amount of joule heat energy that is absorbed by ice. Now we'll go for the next. How much heat is released or lost by water? So for that case, I'm just erasing this portion, because this portion we have written, so that's why I've erased this portion. Next topic is heat lost by water. So how much heat is lost by water? So initial temperature is 10 degree centigrade, and from here it is going to 0 degree centigrade. So 10 degree centigrade of water to 0 degree centigrade of water, and here the whole water is converted. We have to mention that whole water is converted into 0 degree centigrade. Okay, that we have to assume to do this numerical. So assume the heat energy is Q2. So Q2 equals to mass of water mW, specific of water Cw, and del T, that is temperature change. Value of mW, that is 10 gram, Cw 4.2, and here no need to change the value because here it is joule per gram. Okay, and here is also it is given in gram, no problem with that. Del T, temperature difference 10 degree to 0 degree, 10 minus 0. Next, let's see. So it is coming 10 into 4.2, 42, so 420, this much amount of joule. Okay, this much amount of joule heat energy, it is absorbed, it is released or lost by water. Now the question is, as per principle of calorimetry, heat absorbed by a cold body will be equal to heat released by a hot body. So heat absorbed by a cold body is equals to heat lost by hot body. Now, how much heat is absorbed by cold body? Now it is Q1. How much heat is lost by hot body? That is Q2. And these two should be equal. These two should be equal. So let's put the value. So it is coming 210 plus 336 into m. That should be equals to 420. Okay. And it is 336 m. That is equals to 420 minus 210. So it is 210. Okay. Next and last part. So how much ice should melt into water? So that is m into 210 by 336. If you solve it, it will come 0.625 gram. Okay. Now, why I am telling this numerical is very typical. Typical is, you can ask, sir, why we have to take that final temperature will be 0 degree? That is an assumption. By see the answer, we have to choose that we have to find the mass of the ice, not the final temperature. Okay, so you might be thinking you are mixing, so you will find the final temperature. No, final temperature, it will reach up to a limit. Up to how much? Up to 0 degree. Okay, and when the ice will go to 0 degree, the water will go to 0 degree, then when the ice will come also 0 degree, then this point of time, how much ice will melt, that is our answer, which is not clearly mentioned in the book. Okay, so that's why I have told it is a typical numerical. See the process how I have done, and then I think it will be easier for you. Okay, so if you are not able to do it, pause the video and see it, rewind it and see it several times. I think you can able to understand. Now I'll go for the another numerical. I think it is one of the very important numericals among the book. That is question number 7. Okay, I'm just trying to do that type of numerical which have come several times in exam. Numerical number 7 also that kind of numerical. So numerical 7 in my book, it is given a piece of ice of mass 40 gram is added to 200 gram of water at 50 degrees centigrade. Okay, so what thing is given to you? So given mass of ice, that is Mi, how much? 40 gram. Okay, next, mass of water. Okay, how much? Mass of water, it is given 200 gram, and along with it temperature of water, which is mentioned by TW, that is 50 degrees centigrade. This you have to mix, and it is asked calculate the final temperature when all ice is melted. All ice is melted. That means here also a story of state change. But one thing you see, one thing is not given, that is the temperature of ice. When it is not given the temperature of ice, you have to assume that temperature of ice should be 0 degrees centigrade. So 40 gram of ice is at 0 degrees centigrade. You have mixed it up. Okay, then what will be the final temperature? So we are assuming let the final temperature is equals to T or T degree centigrade. The final temperature is T degree centigrade. Okay, now what should I do? What thing is given to here? Now here one more thing is given, that is specific heat capacity of water. I'm not writing the whole thing, I'm just writing CW. It is 4200 joule kg inverse Kelvin inverse. Now one thing, 4200 joule kg inverse, but here you see all the masses are given in gram. So we have to convert it, we have to divide it by 1000, so it will convert into 4.2 joule gram inverse Kelvin inverse. Okay, so that change you have to make. Next, latent heat of fusion. So latent heat of fusion, it is given 336 into 10 to the power 3 joule per kg. Here also it is given kg, so you have to divide by 1000, so it is 336 joule per gram. So that change we have to make. So you have mix it up. So when you will mix it, what will happen? Now when after mixing, I have to write a statement here. After mixing, water will lost heat and ice will get, or ice will gain heat energy. That is a simple way. That means here ice is the cold body and water is the hot body. So our next target is to find out how much heat is absorbed by ice. So first we have to write down heat absorbed by ice. How much heat is absorbed by ice? Now see what I have done. Whenever you have to do also, you have to go by this process. So what is the temperature of ice? 0 degrees centigrade ice. It is there. So from 0 degrees centigrade ice, it have to go T degree centigrade of water, because it is told all the ice should melt. So if it is melt, so 0 degree centigrade of ice should convert into 0 degree centigrade of water first, because this state change it will occur. After that you will go further. So 0 degree centigrade ice to 0 degree centigrade water, first step, and then 0 degree centigrade water to T degree centigrade water. Now you might be asking, sir, why T degree centigrade? Because we have assumed that final temperature of the mixture, it will be T degree. So that ice also go to T degree centigrade and that water also come to T degree centigrade. Okay, so follow the steps. 0 degree centigrade ice to 0 degree centigrade water first, and then 0 degree centigrade water to T degree centigrade water. That steps you have to mention in a form of flowchart. Okay, state change you have to mention separately, otherwise you will don't able to understand that where state changes occur. Now total heat energy Q1, first 0 degree centigrade ice to 0 degree centigrade water, so mass is Mi. So first state changes occur, no temperature change, So Mi into L, that is only latent heat. So here only latent heat is used, that is Mi into L, plus extra 0 degree centigrade water, it converts into T degree centigrade also. So Mi, that is the mass of ice, but that ice is converted into water now. That ice is converted into water, into specific heat capacity of water, okay, Cw, into del T, that is temperature difference. Temperature difference is, previous temperature is 0 degree, now it is T degree. So T degree or T minus 0. Try to see. Here it is the difference only with the previous numerical to here. Previous numerical only we have to see the temperature change. But here along with the temperature change we have to mention the state change. That is extra latent heat. You have to mention here. Put the value. Value of Mi is 40. It is 336. Okay. Plus Mi into Cw, that is 4.2 into T. Okay, so that multiplication we have to do it here. 4 6 are 24, so 2, 4 3 are 12, plus 2 14, 1 12, so 13440 plus 168, okay, 16.8, and here it is 0, so 168 into T. So that much heat is absorbed by ice. Okay, very simple thing. We have followed the steps. Now we'll go for heat lost by water. So we have to write here heat lost by water. So here also we have to mention the flow chart. So initial temperature of the water is 50 degrees centigrade of water, and from here it goes to final temperature, that is T degree centigrade of water. Here you see no state changes occurred, no conversion, nothing has done, only the temperature is changed. So here we have to take the heat energy Q2, it is equals to mW Cw into del T. MC del T. What is the value of MW? 200. What is Cw? 4.2. And what is del T? The 50 to T. So it is 50 minus T. So multiply this thing. So if you multiply, it will come 840, I think. Yes. Okay. So if you multiply 20 here, it is 420, and then it is 840 into 50 minus T. Okay. So rest calculation we will do later. So this heat is absorbed by ice and heat lost by water. So here we'll come to the next part. So I think it is clear. Next part is, as per principle of calorimetry, this two heat energy is equal. So we can mention, as per principle of calorimetry, we all know that Q1 is equals to Q2. So Q1 means this 13440 plus 168 into T, that should be equals to 840 into 50 minus T. Okay, multiply it. 13440 plus 168 into T, and if you multiply, it will come 5 4s are 20, 5 8s are 40, so it is 420, one more 0, one more 0, minus 840 into T. Okay, so change it. 840 into T plus 168 into T, it is equals to 42000 minus 13440. Okay, it's a big number. Okay, you have to do it. Here I have done it several times, so I can write directly the answer, but you have to do it by the step-by-step process. So 8, 0 and 1 0, this much of t, and here it will come. Better we have to do it here. 4 2 0 0 0 1 3 4 4 0 0. Here it is 6, here it is 5, here it is 8, and then 2. Let's see. 0. Okay, 28560, and then t equals to 28560 by 1008. It's a big number. If you do it, it will come 28.3333 continuously, but you will take this 28.33 degrees centigrade. So here you see we are finding out the final temperature. Basic procedure is same, only what extra thing you have to do here, as we have seen a state change is occurred, you have to add this extra thing, nothing else. Rest of the thing is just same what you have done the previous numerical. Okay, I think it is a bit clear for you. Just see it, and then we'll go for the next numerical. The next numerical we'll go for question number 9. We'll do question number 9, 10 and 12. 3 numericals still we have to do. Better I'm just trying to do all the numericals here, otherwise it is little bit of difficult for you. Okay, so we are doing numerical number 9. What it is told? It is told 2 kg of ice melts when water of 100 degrees centigrade is poured in a hole drilled in a block of ice. Try to understand the story. Assume it is a block of ice. Here one hole is made. Okay, and in that hole some amount of hot water is poured. So due to the hot water, some of the ice that will melt. Okay, so how much ice will melt? Now the ice will melt, here it is mentioned, that is mi, mass of ice which melt, that is 2 kg. Mass of ice, it will melt 2 kg. Okay, and mass of water we don't know how much water is put here. Okay, it is not there. So mass of water mw, that is m, let. Okay, and temperature of water, that is Tw, that is equals to 100 degrees centigrade. Okay, now specific heat capacity of water, Cw, it is given 4200 joule per kg Kelvin, and one more thing is given, that is specific latent heat of ice, that is capital L, that is 336 into 10 to the power 3 joule per kg. Simple story is how much the ice will melt. To try to understand it, whenever you have to put water here of 100 degrees centigrade, so it will go up to that much time until the temperature of water will reach to 0 degrees centigrade. Why I am telling this? Because as the temperature of ice cube, it is not mentioned, so we have to take its temperature is 0 degrees centigrade. So you have to put water over here, that temperature is 100 degrees centigrade. So it is clear that water will lost its heat energy and ice will absorb heat energy. Up to how much time? Up to that time until the temperature of water will reach at 0 degrees centigrade. So this process will continue, this melting will be done until this 100 degree centigrade of water is converted into 0 degree centigrade, and when this water is converted into 0 degree centigrade, then no heat exchange will occur, and then this process, the melting process, will stop. So here we have to assume that final temperature should be equals to 0 degree centigrade. You have to understand it. Okay, you have to understand it that the temperature of water should reduce up to 100 degrees centigrade. Now, coming to the heat absorption and loss. So here we have to come heat absorbed by melted ice. How much heat is absorbed? Here it is told, if you see the question, it is told that ice melts. Ice melt means from 0 degree centigrade of ice to 0 degree centigrade of water. No changes occurred. Okay, no temperature changes occur, only the state is changed. So how much heat should be absorbed? So heat absorbed should be equal to the latent heat, because only the state changes occur, and latent heat equals to mass into L, that is m into L. What is the mass here? 2 kg. What is the latent heat? That is 336 into 10 to the power 3. So that much amount of joule. So here it is 672 into 10 to the power 3 joule. Okay, so here you have to see one thing, that as the mass is given in kg, so no change or no conversion we have done here. As it is also kg, it is also kg, we have directly multiplied. If it is gram or kg, then this change will be occurred. Now, heat lost by water. So how much water you have given? You don't know the mass. But what is happened with the water? Now you have given 100 degree centigrade of water of certain mass, and that it will reach 0 degree centigrade of water. Okay, until this process will not stop. So 100 degree centigrade water, it will reach to 0 degree centigrade of water. So here you see, here no state changes occur. It is also water, it is also water. Only temperature is changed. So heat Q equals to mass of water into specific heat capacity of water into del T. Mass of water, what we have assumed, that is small m. Cw, it is 4200 into temperature difference is how much? 100 minus 0. So if you see here, it is 42 or 420 into 10 to the power 3 m, this much amount of joule. Okay, now as per principle of calorimetry, if this process is stopped, then that to heat energy will be equal. So we can mention, as per principle of calorimetry, what is the heat absorbed by melted ice? If you mention it by Q1 and it is Q2, so it is Q1 equals to Q2. So write Q1 is 672 into 10 to the power 3 should be equals to 420 into 10 to the power 3 into m. 10 to the power 3, 10 to the power 3 cancel out. M, this much equals to 672 by 420. So if you solve it, it will come 1.6 kg. So that much amount of water is used, okay, to melt the ice. Okay, you just calculate it, it will definitely come 1.6 kg. Okay, coming to the next numerical, I am doing a little faster because whenever you have to see length of the video, that might be very long and you think that these numericals may be very hard. But according to me, this is the most easiest numerical you have ever done, because here simple thing, all the equation is been set, you have to go as per equation. Okay, so before that you have to write that flow chart I have mentioned. In question number 10, I think you can able to understand this very clearly, and this numerical is given in question number 10, but it is the easiest one. Calculate the total amount of heat energy to convert 100 gram of ice at minus 10 degrees centigrade to 100 degrees centigrade. Very interesting thing. What thing is given? The mass of ice is equals to 100 gram. Temperature, or we have to mention initial temperature, that is Ti, it is minus 10 degrees centigrade, and here from here you have to take final temperature, that is Tf, it is 100 degrees centigrade. Very easy. Okay, here I think whatever the doubts you are having, that can be solved. Before that, specific heat capacity of ice, that is Ci, it is given 2.1 joule gram inverse Kelvin inverse. Okay, and specific heat capacity of water, that is 4.2 joule gram inverse Kelvin inverse, and latent heat of fusion, that is 336 joule per gram, that is gram inverse. Okay, so these informations are given to you. You have to find total heat energy. Okay, so total heat energy means heat absorbed by ice. Now follow the steps. If you understand this numerical, then I think there shouldn't be any problem with any another numerical. 100 gram of ice is minus 10 degrees centigrade. So that is the temperature of ice, minus 10 degrees centigrade of ice. So it will reach up to 100 degrees centigrade of water. In which state? So minus 10 degrees centigrade of ice, it will don't able to convert directly to 100 degrees centigrade of water. It should follow some steps. What are the steps? Now minus 10 degrees centigrade of ice should convert 0 degrees centigrade of ice. Okay, and after that 0 degree centigrade ice to 0 degree centigrade of water, that is a phase change, and then 0 degree centigrade water to 100 degree centigrade of water. So that step it should follow. Okay, minus 10 degree centigrade ice to 0 degree centigrade ice, 0 degree centigrade ice to 0 degree centigrade water, 0 degree centigrade water to 100 degree centigrade of water. Okay, so here these steps we have shown to change the phase, to show the phase change. Okay, otherwise it is not possible. So write the heat energy Q, minus 10 degree centigrade to 0 degree centigrade. So here temperature changes occur. So here temperature changes occur. So simple equation we have done earlier, that is mc del T, that is mass of ice Mi, specific heat capacity of ice Ci into del T. Okay, plus coming to the next step, 0 degree centigrade ice to 0 degree centigrade water. So here you see temperature is not changed. What is changed? Phase change. So phase changes occur. So here what heat energy you have to take? You have to take latent heat. So Mi into L, because you know Q equals to ml, plus 0 degree centigrade water to 100 degree centigrade water. Again the temperature change, and now the total ice is converted into water. So mass would be same, that is Mi. Okay, what is the mass of ice? That should be the mass of water, but specific heat capacity will be Cw into del T. So better you have to mention it is del T1 and it is del T2. That is the temperature difference 1 and temperature difference 2. Now put the value. Mi 100 into Ci 2.1 into temperature difference, that is 0 minus of minus 10, so plus 10. Okay, plus mi into L, so 100 into 336 plus mi, that is 100, Cw, that is 4.2 into 0 degree to 100 degree, so temperature difference 100 minus 0. Now let's see, 2.1 into 10, so 21, so 2100 plus 33600 plus 42000. Okay, now add this two, so it is 42000, and then 2100. Okay, 00777. This much amount of joule, or you can write 77.7 into 10 to the power 3, 10 to the power 4 joule. So this is the total heat energy absorbed. Okay, so if you do these steps first, then your numerical should be very much easier. Okay, not losing much time, I'll go for the last numerical, and see, it is your task to do rest of the numerical. It is given to you. Okay, if you have not understand it, just pause the video and see it once again. I think you can able to understand. Next question, question number 12 is also very easy. Comparatively, question number 6 and 7, here it is little harder, but rest it is very easy. Question number 12, it is told 200 gram of ice at 0 degree centigrade converts into water at 0 degree centigrade in 1 minute when heat is supplied to at a constant rate. Okay, in how much time 200 gram of water at 0 degree centigrade will change it 20 degree centigrade. Okay, take the specific heat capacity, specific latent heat of ice is 336 joule. So first of all, it is given mass of ice, that is 200 gram. Okay, it converts 0 degree centigrade water, 0 degree centigrade ice to 0 degree centigrade water. So simply here no heat temperature changes occur, only the state change. So what heat is needed? The heat absorbed, that should be the latent heat, and your specific latent heat L, it is given already, that is 336 joule per gram. Okay, so how much heat is absorbed? The heat absorbed, that is your latent heat, is equals to M into L. What is the mass? It is 200 gram, 336. Okay, so it is 67200 joule. Okay, now there is a twist. It is told that this much amount of heat energy is supplied in 1 minute. Here one thing mentioned, that is time equals to 1 minute, means 60 seconds. Heat absorbed and time. So heat absorbed means this is your total heat, that means energy. Heat is a form of energy, so that much energy you have supplied with a time of 1 minute, that is in 60 seconds. Can we able to find rate of flow of energy? Rate of flow of energy. So rate of flow of energy that is equals to power. Now you may ask, sir, we have done rate of doing work. It is actually power. We all know that the ability to do work, it is energy. So rate of flow of energy is also power. Rate of flow of energy. So power equals to, we can write energy by time. Okay, so how much energy is there? 67200. Power time 60 seconds. Cancel out. 6 ones are 6, 6 ones are 7, 1 2, 6 twos are 12, 0. Okay, so 1120 watt. 1120 watt. So by which instrument you have to supply the heat energy, that power you have calculated. Okay, then what will happen? Now we'll come to the next step. That is the next step of the numerical. Next step is, in how much time 200 gram of water, because you see, by absorbing this much amount of heat, this 200 gram of ice is converted into water. So we can mention mass of water is now 200 gram. Okay, what is its temperature? So temperature of water, it is 0 degree centigrade now. Now it is converted into how much? 20 degrees centigrade. So final temperature TF, that is 20 degrees centigrade, right? So how much heat absorbed? We know that heat absorbed Q equals to, see here the temperature is changed, that means 0 degree centigrade of water to 20 degree centigrade of water. So here no phase changes occur, only temperature is changed. So temperature change means MC del T. So it is MW CW and TF minus TW. That is the del T. What is the value of MW? 200. What is the value of CW? Okay, CW, though it is not given here, but you know that specific heat capacity of water, CW equals to 4.2 joule per gram Kelvin. That you have already done in several numericals. So here you have to mention 4.2. And TF minus TW, it is 20 minus 0. So it is 20. So here 84. So 200 into 84, and it is 16800. That much amount of joule. That much amount of joule heat energy, it is absorbed. Now the question has come, how much time it will take? See, we have supplied the heat energy, this much amount of heat energy, by same instrument whose power is this. So we can mention that as power P equals to 1120 watt. Okay, and energy, that much heat energy it is absorbed, that E equals to Q. How much heat energy is absorbed? That is the energy supplied by the instrument, and that is 16800. This much amount of joule. Now you have to find time. Let the time is equals to T, and we know energy is equals to power into time, and time is equals to energy by power, right? Time is equals to energy by power. So energy equals to 16800 by 1120. Okay, so if you calculate it, it will come 15. Okay, so otherwise you can go by step. Okay, and here it is also going by 2. it is also going by 2. Now it is going by 15 seconds. Okay, our answer has come. So this type of numericals will ask, I know whatever the numericals we have done, what it seems to be that very easy. Yes, it is not. You have to think little bit, you have to think the steps, and then these numericals will be very much easier for you. Thank you.